8, lesson 7. So problem solving in the ambiguous case of the sine law. So again, we're going to be going over the sine law and how there actually is a case where you can get potentially two answers. Again, I already said this to you, but for the video, there's parts where it says protractor and ruler. We're going to kind of summarize those points and just kind of work through them without those today. Okay, so students are asked, so warm up. Students are asked to determine the measure of angle ACB in the triangle of AB6, AC4, and ABC of 30. So here's the thing. You kind of see there's actually two situations. There's a 30 and a 30. Okay, so there's 2 points here at which the 30 makes 4, but clearly different triangles, yeah? Okay, so it says use the ruler protractor, so I was talking about, to represent the given information. So they're saying measure, is that actually 30 with your protractor? Yes, it is. Okay, those are actually 30s. Without using a measuring device, estimate the nearest 10 degree of the measure of angle ACB. So what do you think ACB is here? Okay, that's fine. They said 50, but close enough. You said 35, 40, but it's less than 90. Okay, that's good. So 50 for Scott. And then how about ACB on the second one for Brittany's? Yeah, 110, 120. They went with 130, but I think those are all good guesses. I'll just stay with what the book notes have, but I probably would have said 120 myself, but yeah. Definitely obtuse though, right? That's the point. Okay. Okay, so let's keep going here. So in each case, use the sine law to determine the measure of angle ACB to the nearest degree. So we're going to do the information we have in front of us and do sine law for Scott and for Brittany. Okay, I'm going to go ahead and pause the video and let you guys do that now because you know how to do that. So I want you guys to go try to do that. All right, so for Scott's setup, Scott should have went, you know, sine C over C equals sine B over B. And that would be sine C over 6 equals sine 30 over 4. So he simply multiply by 6 and then sine inverse, right? Because you have to inverse in your final degree measure. Okay, so you multiply this whole thing right here by 6, and you're going to sine inverse that value. That value that you're going to inverse is going to be 0.75. So you're going to get 49 degrees. Now Brittany there, she's going to have identical work, okay? But since ACB, we know ACB is not what? Less than 90, right? So what happens is that 49 is the reference angle. Okay, so 49 is the reference angle. We know she's clearly bigger than 90, so that means she's in the second quadrant if you think about unit circle. So how would I figure out her answer? I would go 180 minus 49 to get the obtuse angle. Right, so 131 is Brittany's angle. Because her identical work, you're going to see that this is where you guys got to pay attention a little bit, because she does identical work. Her calculator is going to say 49. So you need to be aware of, like, okay, that's definitely not 49, so it must be the other side, the obtuse angle from 49. Okay? So in this particular example, information given allowed us to draw two different triangles which produce two different answers to the same question. This is called the ambiguous case of the sine law. Okay, but how do we know if the given information will produce a unique solution or two different solutions? So the next thing we're going to do is we're going to figure out what's the trigger for when we should expect two answers. Okay, that's what we're going to be doing today. Okay, all right, constructing triangles. So triangles to be constructed given 3 measurements, one of which must be the length aside. The following explorations be completed to use a compass protractor. Again, we're going to kind of geometry sketch back. That's pretty cool. So I can show you that sometime. But we're just going to kind of just roughly go through these. So investigation 1, if you're constructing congruent triangles, so just do the best you can on your paper here. So we're going to do QPR with PQ3, PR4, and QR6. Is it possible to construct a triangle with the same measurements which is not congruent to the first one? So they're saying is, if I draw PQ, so this is PQ, whoops, I'm going to say this is Q like my notes here. And then it says PR. little bit longer, is 4. And then QR is 6. So what it says is it possible to construct a triangle with the same measurements which is not congruent to the first one? So the question here is can I do 3, 4, 6 a different way but still be congruent? And that'd be a no. I cannot draw a congruent triangle unless they're all the same sides, because congruent means the same. It's kind of a weird, redundant question. So let me say that again. This is a side, side, side example. What that means is you have all the sides. What it's saying is it possible to construct a triangle the same measurements which is not congruent? It is not. We can't make a triangle that's 3, 4, 6 that is not congruent, because they'll be matching up all the sides. Okay? That's what they're saying. So this would be a no. Side, angle, side. So let's look at side, angle, side. So QPR is PQ's 5. So we're going to go, this time it went this way, PQ, stay, so we're going PQ, that's 5. We don't know PR. We know the RQ is 4, it says, and we know the angle measure here is 40. That's the information they give us in the question. Now, sketch that. We sketched it. Is it possible to show a triangle of the same measurements not congruent to that one? So this one, it's called SAS, side, angle, side. This one's also a no, and I'll explain it this way for you. Obviously, if I draw a triangle of 5, 4, 5, 4, it has to be 5, 4, 5, 4. Those are going to match, right? Now that we've done that, this 40 is going to make a proportion. We can use cosine law to find this missing side, right? So no matter what, this side, we know what it is. So that can't change. So no, we cannot draw a congruent triangle, a non-congruent triangle that's in SAS form. So if what you're figuring out is congruent statements. If you have all 3 sides, that's a congruent statement. It's congruent if they have all 3 sides. If they have a side, angle, side, they're congruent. So if I drew a triangle like this, just randomly here, it's a little bit different. If I said this is 40, and this is 4, this is 5, those are congruent. Okay? So I'm showing you is that another thing to pay attention to. What we talk about, what's really important with sine law, to use sine law, to have what? Comparisons, right? And so here, we have all 3 sides, so we kind of have all the information. So if I draw that with all 3 sides, there's no way I can make that non-congruent. This one, we essentially have 3 comparisons. What I mean by that is I have a side, and I have the angle that makes the side. So that locks in that value. So that makes it not, we can't draw something different that's not congruent. Okay, so side, angle, side. All right, now let's look at angle, side, angle. Let's see what you guys think about this one. So angle, side, angle, we're going to go P, R, Q. So P, R, Q. We're going to say PQ is 3, PQR is 40, and QPR is 30. So based on maybe the previous 2, what would your guess be for this one? So what did I just talk about in terms of comparisons? So this is what's tricky about this one. You said yes, a couple of guys. That's a good guess. It's not correct. It is no again. Okay, and this is why. Well, if you have 2 angles, you really have how many angles? You really have 3. So we know what angle makes 3. So that means we know what 40 makes, and we know what 30 makes, which is the other 2 sides. So again, all 3 sides are locked in. So if you have an angle side angle relationship, you can make them congruent. So you can't draw something that's not congruent to that with the same information. Okay? So again, those first 3, side, 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 angle, all have 3 pieces of information for one side. Either the angle that makes it or the side itself. Now this one, okay, side, side angles. This is the one we're focusing on today, so if you want to go ahead and assume you're right, it is yes, you can draw something else congruent that's not the same. So let's look at the first one. All right, so we have PQ, so we have P, R, Q. So side-side angle. So they gave us PQ is 6, PR is 4, and PQR is 40. So now, what side is the mystery? RQ. RQ, we have nothing to lock RQ to. And so that's kind of your tip that this is not a good congruent statement. SSA is not a good congruent statement. But then in this case, it tells us for the ambiguous case, this is where it comes to the possibility of getting 4 again. So if I do 40 makes 4 here, there's also a spot where I can draw it like this. And this thing comes a little bit lower. Not lower, sorry. It still comes out the same. The point is this is a terrible drawing. Okay, but these are both 4. There's 2 locations which they can be 4. Okay, and that gives us 2 solutions. So when you have SSA, you can look for the obvious chance for the ambiguous case. Okay, it's drawn. It's drawn a little better on here, and it has to do with circles, and we're going to get to that in a second. So let's talk about that now. So you're looking for SSA. That whole part of that investigation was we're looking for SSA. Okay. All right, so investigation 1, we found that the cases of the 3 sides, side, angle, side, angle, side, angle, only 1 triangle could be drawn. However, in the case of SSA, there are 2 possible triangles that could be drawn. Given an SSA triangle, there are actually 3 possible situations technically. So there's 3 situations which happen with SSA. Diagram below is going to help us with that. So again, I'm going to kind of walk through these. You can just watch for like the compass and stuff. So what it says is set the compass to 3.5. Place the pointer at A. So you're placing it here. So that you'd have a compass doing like this, like a compass, and it'd be like right here. See like a thing that virtually like a compass there? So like the point of the compass is here, and then you're going to rotate it on this line. Okay, that's what's happening. You guys understand what I'm kind of saying there? So the pointer, so you have a compass, right? There's a pointer and a pencil. The pointer is on A. You're gonna make the measurement of it 3.5 centimeters in your book. And so yeah, so this obviously this is not 3.5. I'm projecting this, right? But on your book it'd be 3.5 centimeters. And what happens is it's going to be like right here, and then we're going to rotate it. We're going to rotate it, yeah. Okay, we're going to rotate it, and what happens when you rotate it? It does like this, a little circle. Oh, like a north-south compass? No. Yeah, drawing compass. Yeah, sorry. So how many points are possible to be on point C is the question. So for point C, so what they're saying is there's 2 intersections when you do that. So that's one option for SSA. So that means that 2 answers is possible. Okay, and that's because of the symmetry of a circle. Okay, because of the degree measure. Now, let's look at case 2. And again, this is, if you just want to just not write this down, if you just want to just watch and listen, this part's kind of just setting things up, but we'll get to more direct examples in a little bit if you're getting a little bit overwhelmed. 1 unique triangle. Repeat the instruction case 1, set the compass to 3. So if you set the compass to 3 on your book and you do the same thing we talked about, what happens is it hits it exactly once. So that's an exactly 1 solution. Okay? And then if you set it to 2, you get what you think? 0 solutions, correct. You set it to 2, it's here, and it goes like this and misses completely. So no solutions. So we're used to that pattern, right? Discriminant 2, 1, 0. Same type of thing happens here. There's possible 2 answers, 1 answer, or no answers. Okay. All right. Continue on to investigations here. That's what makes this lesson long. This part should help a little bit. Okay, so in previous investigation we discovered, again, recapping what we just did, the last 2 pieces. Side, 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 angle, side, angle, side, angle, only 1 solution was possible. But in the case of SSA, 0, 1, or 2 are solutions are possible. We shall investigate SSA scenarios to figure out when that happens. So we're looking at, consider ABC 6, ABC's 30, angle ABC 30, and we are going to consider 3 different measurements for AC. So here we go. We're going to do it. AC is 2.5. Okay, so an AC is 2.5. All right, so step 1, sketch a rough diagram below. So we want to sketch a rough diagram below. So we have AC or potentially AC. That's not too good of a diagram here. Draw a little bit more similar here. So like this length is close to that length. Yep, there we go. Okay, so kind of see an example of this could possibly be 2 solutions. And so what I'm trying to show you is like we could put the point here or put the point here. So use a sine law to determine sine C. So let's use sine law to use sine C. So here's the thing. We're either finding this or we're finding like this, right? Because the 30, that's what 30 is making. You kind of be making 2 pieces. Well, here's the thing. Those are going to be the same length. Do you see that? This essentially is an isosceles triangle right here. So that's not going to change stuff for us, okay? So we go and do that. So sine C or sine B in this case. We know sine C we don't know. So we don't know what angle C is. This is C right here, sorry. Or here. Okay, we don't know what C is. We do know what they make C, right? They tell us that C is 2.5. Sine of B, we had sine of 30. And then side B is, oh, excuse me, I switched them. Sorry. B makes the 2.5, right? See this angle? It makes that side, or if it's over here, it makes that side. But either way, that side's 2.5. I just had the wrong side, sorry. So then, sorry, what is side C? 3, yeah, my bad. So it's times the 3 over inverse sine. Okay, you get 0.6. 0.6, and then you get 37. But it could be 37 or what? Because we clearly see by drawing this that there's actually 2 options. Right, there's the 37. Sorry for angle C. My lines are everywhere. Let me try to make it this here. So we have here. We have here. Draw a little bit higher. It's hard to do. Okay, and so, sorry, we're going for angle C. So this right here, angle C is 37, or it can be 143, sorry. And so what that means is this right here is the 37, right? This is the other C spot. Sorry if you're confused. I didn't put. So this would be the 143. Mine's not to scale. Mine's not great. Okay, it definitely should be a little bit wider looking, but that's what's going on. So there's 2 possible locations for C. The far location makes a smaller degree. The closer one makes a bigger degree. Okay? SSA, yep. And we're going to go through the other couple here. Okay, so then ACB, again, is the 143. Let's just finish this one out. Determine the measure of BAC. So BAC would have to be, there's 2 options for BAC, right? BAC is 37 plus 30. See how it could be bigger or smaller? Okay, so 37 plus 30 is 67. So that would be 113. There's one option. Sorry, it's right here. One option is 113. And what's the other option? So it would be 30 plus 143. So that's 173. So how much is left? 7. So the 143 and the 30, right? Because if it's this one, this is 143, this is 30, so what's that have to be? That has to be 7, so it's obviously not the scale. Be a little bit smaller too. Okay? Right, the longer one is this one. So we're kind of doing 2 at once, Joel. So here's a possible for C. That's a possible triangle. If it's this, Joel, it's 30, 143, and 7. If it's this one, it's 30, 37, and see how that's now obtuse? 113. So there's 2 different triangles we're looking at. Okay? So state the solution to the problem. So the solution to the problem for BAC is 7 or 113. So that means that that's 2 answers. Okay. You're going to make the comparison here in a second. I know a lot of numbers thrown at you here. So if AC has to be 4, what that does is 4 puts it, up to here. This is 3, that's 4. That makes this have to come up here. And it kind of locks us into one type of triangle. We don't have 2 options anymore. What's the difference between case 2 and case 1, do you notice? Correct. So you see up there in case 1, we did 2.5 was the away side. And that 2.5 being shorter than the 3 helps us have 2 options. The 4, I can't have 2 options because I'll overlap. If I do 4 this way, it's going to overlap because it's bigger than the 3. So what you're looking for is when you have the side-angle-side, if the side away from the angle is bigger than what you have, then you're just going to have one solution. If the side away from the angle is smaller than what you have, you're going to have maybe 2 options. Okay, that's what you're looking for. That's the big key today, okay? So let's go ahead and finish this one up. Okay, so sine C, so do the same thing we just did. So here's C. We know that this right here is 4. So sine C, we don't know, makes 3. So sine of C makes 3. Sine of 30 makes 4. Multiply the 3 over, we're going to get sine of C equals 0.375. We inverse that, we get 22. So 22 degrees is angle C. Now, a couple of things I want to point out that why this makes sense here. Just went through the sine law kind of quickly. Yep, so I did right here, I times the 3 over. This value multiplied by 3 is 0.375. I inverse 0.375, I got 22. Reference angle is just the output. So reference angle means it has to be from 0 to 90. Yeah, that means it's not obtuse. But one thing I want to show you, if 30 makes 4, does it make sense that 22 makes 3? Yeah, because 22 is smaller makes 3, 30 is bigger makes 4. 4 is bigger than 3. Okay, angle C, 22. ACB, 22. If we wanted to find angle A, we'd add 30 plus 22 is 52, so it would be 128. So that's asking us here. All right. So questions before we go on to case 3 here. So far we just did what? The first one, how many answers were there? The second one, how many answers were there? And the last one we're going to do is going to be 0. Okay? Everybody staying with me? I know this is a little bit higher level. It's a lot of conceptualizing, but you got to ask questions. Okay? So Joel's the only one that asked questions so far, so everybody else keep it going. Okay, so AC is 1 now. So the problem with this is, physically with the triangle, a 1 can't close it off. And so it looks kind of weird. It just, can't make it. It can't do it. And so if we do sine law, we say, well, let's say you didn't notice that. If we do sine law, it would be sine of C over 3 equals sine of 30 over 1. If you times that over 3 times sine 30 over 1, you get sine of C is 1.5. That's immediately a problem because why? It's greater than 1. Remember, unit circle, your sine can't be bigger than 1, right? Because your hypotenuse is 1. Okay? So what happens is when you put your calculator, you go sine inverse 1.5, it's going to say error. That means no solution. That's fine. But I want you guys to be tipped off from unit circle stuff. When you see sine or cosine of 2 or 3, you won't get anything. Okay? It was 1. And there's always a hypotenuse within the unit circle. Now, if you're talking about a different circle, if you have a circle with a radius of 5, then things change. But for what we're dealing with 1.
So it has to be like 1 or below?
Yeah, remember your sine and cosine values are constant change between 0 and 1 continuously, and -1. And so any values between -1 and 1 are good for sine and cosine. Okay, so that's it. We just walked through how you get 2 and 1. So again, what are you looking for? You are looking for two solutions, you're looking for that side to be smaller. Okay, 2.5, but not too small. If it's too small, there is no solution. Okay, if it's bigger, you're going to get one solution. So let's fill this in. We'll do some examples, and we'll call it a day. Well, the information they give you if you label it, yes. Okay, but remember it's SSA, right? So look for SSA. Determining factor depends on how the reference angle compares to the given. Complete the following statements. If the reference angle is greater than the given angle, there will be 2. Good. If the reference angle is less than the given angle, there will be 1. If the reference angle does not exist, like we can't get it, there's none. So this is when we do our work at the end there. Greater, you're thinking side. So if we go to number 2, if the reference angle is greater than the given, so 2, let's see here. Oh, you might be right here. Hold on. If the reference angle is greater than the given angle, there'll be 2 solutions. So reference angle, we got 37. So on the first one, we got 37, right? And the given was 30, so that was greater. Right. No, yeah, angles, yeah. But good, that's good. Okay. All right. The case for 2 solutions can also be determined by looking at the 2 given sides. Sine of C over C equals sine of B over B. Then B over C equals sine of B over C. All right, I'm not going to read more to you. Let's get to an example here. All right, let's try it. Without using the sine law, determine which of the following cases there's exactly 1 solution. They don't want you to solve here. They want you to set up and say 2 answers, 1 answer, no answers. Okay? So let's just calculate angle C, even though you're not supposed to. Okay, angle. So you still can sketch it. So we have ABC. So let's just draw ABC here. So we got A. If you draw it, remember you're drawing it not to scale, so it could look off, just for reference. So side B is 12, side C is 10, and angle B is 56. Okay. So the side opposite of the given angle, is it what? Is it greater or less than the other side? Greater. It's greater. So what happened in our cases when we did that? 1. It was case 2. So we expect 1 solution. Okay, so if you look back on your case, you look at case 2. Case 2, the angle we had made a 4, and we had a 3. Right? So the angle we have makes a 12. We have a 10. So this is bigger. There's only one way to do that one. Okay? Questions on that? All right. Part B, calculate PQR. So let's look at PQR here. So let's draw a PQR triangle again. It's not to scale. Just drawing it for reference. PQR. QPR is 41. RQ is 3. And PR is 4.2. And so in this case, right, but we can't say 2 because it also could be what? None. None, right? If it's smaller, it's either 2 or none, if it doesn't quite reach. Okay, so we don't know. So they just said that you can put not exactly 1. So you guys see, 41 makes 3, which is smaller than 4.2. If it's smaller, you can have 2 solutions or no solutions. They said not exactly 1 in the notes, or you can say 2 or none, whichever you want. That's your options. Sorry. Well, because 1's the only way you can, like 1, the first one has to be 1. The other one's 2 or 0, so just not 1. That's all they're saying. Because you can't have 3, 4, or 5. It's 0, 1, or 2. Okay, now we'll actually do the work here, and we'll be done. All right, are we ready? Yeah, no, okay, well, get ready. All right, final all possible measures of angle C in the following triangles. So Let's draw it first, and let's see what we expect. Let's do that first, okay? So again, I'm just going to draw this roughly. We'll do an ABC. ABC. Angle A is 50. 5 there. Side A is 7.5. And side C is 9.5. So the angle I have makes a smaller side than the adjacent. So what's that mean? Okay, hold on. Yeah. Right, so it means not 1. Okay, so now we have to do the work to solve. Because we know what 50 makes. So we just do our sine law now. So we do sine of, and they want to know angle C, by the way. So sine of C over 9.5 equals sine of 50 over 7.5. Times the 9.5 over. When you times the 9.5 to this value, it's going to be, yeah, you're going to get to that. You're going to get 0.9703. Then we sine inverse. Okay, and we get 76. So we did get an answer, right? But we said it was not going to be 1, so there's another answer. Right? So let me say that one more time. We know by the cases we just did, the angle it makes a smaller side than the one that's next to us. So that means there's 2 or no solutions. We just found out it's not no solution, so we didn't get error. So there's 2 solutions. Right, that's what you have to come up with. 180 minus 76 for 104. And so that's your 2 solutions. 76 or 104 is the possible answers for angle C. Okay, so man, it's 2 or none or 1, and then you'll know it's none when you get error. Otherwise, it's 2. Yes?
So it was 2 because 7.5 is smaller.
Right. 7.5 is smaller than 9.5. If this was 10.5, we'd be expecting 1. Okay? All right, next one. Actually, so they switch them here. So then they say they switch A and C, so they switch the relationships. So now it's going to be expecting 1. Right, so let's draw the same triangle. Go to A, B, C. Side A is 9.5 now, side C 7.5, and angle is 50. So the 50 makes the 9.5, which is bigger than the side adjacent, so we're expecting 1 solution. We're expecting 1 solution.
Well, it says A equals 9.5 centimeters, so that means across from
Yeah, side A is made from angle A, so across from angle A. Okay, so set this guy up. So sine of C over 7.5 equals sine of 50 over the 9.5. We times the 7.5 over, you're going to get sine C is 0.6047. We inverse that, and we get 37. So C is 37 degrees. A couple things to think about here. You can always check your work on that if you're not sure, in the sense of 50 made a 9.5, 37 made a 7.5. That makes sense, right? 50 is bigger than 37, 7.5 is smaller than 9.5. So the right angle made the right kind of proportion. Okay, all right, we'll stop there. Okay.